Today we're going to work on drawing a Lego and taking a look at the use of variables in Onshape. A Lego, while seems like a simple thing to draw, is a little more complicated due to the number of variables and the design. So as we can see, this is a regular 2x4 brick Lego. And if we look on the bottom, it has 3 cylinders to help mount to the pegs. Some of the things we need to pay attention to in Legos that are universal are the peg size, how tall the pegs are, and for the distance of every peg, you can stack an individual Lego on top of each peg to have 4 in a row. So these various variables we're going to call peg diameter, peg height, brick height, and for people familiar with Legos, there's such thing as what's called a plate, and it takes 3 plates to stack to equal a brick, so we'll have plate height. And then we'll have what's called brick unit, which is 1 square width and length of a Lego. So let's go ahead and start our new drawing. I'm going to enable mine, label it period, last first, Lego Part Studio. So whatever period number you're in, last and first name, for turning in the assignment, Lego Part Studio, or PS. Now, when we get into the Onshape, the first thing we need to do is establish our variables. To establish your variables, you're going to look for the variable button. It looks like an X in parentheses. So the first thing we're going to do is give our variables a name. So we'll start with peg height first. We're going to call that peg H. And that value is 1.6 millimeters. As I hit enter, I can see it auto-calculated that as 0.063 inches. Well, I want to work in millimeters for this drawing, so I need to switch my units. To switch my units, I can go up here to the menu button, workspace units, change from inch to millimeters. And now it shows up in millimeters. I'm going to add more variables, so I had peg diameter, and the value of that was 3 peg heights. And so to use a variable that I've already established, I use the pound sign, so shift 3, and then I can choose a variable from the list. Peg height, and I said it was times 3. So I can actually type times 3 in the value box, and hit enter, and it calculates it at 4.8 millimeters. Variable again. So brick unit, which is the length and width of 1 brick. And that is variable peg diameter plus 2 peg heights, because the height of a peg is the same as the distance from the edge of the peg to the edge of the block on both sides. So height of peg plus variable peg H times 2. And that makes it 8 millimeters. Now I'm going to have plate height, or plate H, and that variable is peg height times 2, and that's how tall the plates are in Legos, not including the pegs. And then we have brick height. And brick height is 3 plate heights. So plate height times 3. And so now that we have our 5 basic variables established, we can draw almost any Lego in our Lego box. In this Part Studio, I've already used the import feature to import a PDF of various Legos I found on Google. This document has all the Legos available, or almost all of them available in many of the kits out there, and so you could use this as a means to create a number of different Legos, as I did in a number of the videos that you can download. So, we've got our variables established. Now we're going to start by drawing our Lego. We'll put our sketch on our top plane, and then hide the planes so they don't get in the way. I can view top, and I'll start by drawing my rectangle. I'll start from the origin just so it constrains it a little bit easier. Just draw the rectangle any size, but try not to make it too big. Click once. Now normally in Onshape you can type in the variable box, in this box here, the measurement you want if you know you're doing absolute measurements. But I cannot type a variable symbol in there, which is the shift pound sign, because shift numbers are quick keys for your various views. For example, if I try to type shift 3, that is the quick key for my left view. Shift 1 is my quick key for my front, 2 for back, 3 for left, 4 for right, 5 for top, 6 for bottom, and Shift 7 for isometric. These quick keys actually make it much quicker to draw if you can remember them. So, we start with our top view, and instead of typing in a dimension, we're going to hit Escape, and then we're going to use the Dimension button to add dimensions to our Lego. So first I'll dimension the side length, and since I'm drawing a 2x4 brick, I'll dimension this variable, so hashtag or pound symbol, and this is going to be brick unit times 2, because I want 2 pegs. The length, I want 4 pegs, so it's going to be our variable brick unit times 4. Now that I've done that, I can extrude it. And if I was making a plate, I could say variable plate height or I can do variable brick height. Now I have the overall shape of my brick. Now Legos aren't this exact perfect size due to tolerances so that they fit together when they're stacked and can be easily taken apart. But for our purposes, we're going to draw them without tolerances. So now I'm going to put a sketch on the top of my brick and draw the circle for my peg. Just draw it approximately the right size. Then we'll use dimension. Remember, D is the shortcut key for dimension, so that'll make things faster. D, click on circle diameter, and this is going to be peg diameter, so variable, peg D. Enter. Now we need to dimension how far away the circle is from the edge. You can do it one of two ways. You can click the center of the circle and the edge of the brick and drag, and this will be variable brick unit divided by 2. Or we can click the edge of the brick and the edge of the circle, and that gives us the distance from the edge of the brick to the tangent outside of the circle, and that is peg height. both end up with the same answer, so both work fine. Now that I have my one circle, I'm going to go ahead and extrude it. And the height of the circle is going to be peg height, variable peg height. Now, I'm going to use linear pattern to replicate that pattern, the peg. So first I click linear pattern. I change from part pattern to feature pattern. Choose my feature, which happens to be the last extrusion I did. Click in the direction box and click the direction I want to go. I want to make them go parallel to this edge. I want 4 of them. And I want my distance between the pegs to be a brick unit, which is the unit of one length of a small Lego brick. Tab to confirm. It looks okay, so we can click OK. Or, if we want to do 8, we can do another row by clicking second direction. Clicking in the direction box, clicking our parallel distance. This time my instance count is going to be 2, and my distance again is going to be brick unit. Tab to confirm. Click OK. There. Now my Lego has pegs on top. It's not recommended you put text on your Lego yet on the top of your pegs because that can interfere with the shell process on the bottom of your Lego. You can do the text last. So now I'm going to turn my Lego over and put a sketch on the bottom. New sketch. But I need to see where the pegs go on the bottom so I know where to make the cylinders. To do that, I can turn it back over and use the Use Project button. Now if I click on top of the peg, it puts a circle on the bottom of my sketch, showing me where that circle is, kind of casting a shadow. So I need to project 3 circles. Now I can turn it back over, and I have where my 3 pegs are. Now I'll draw 1 circle in the center of those pegs. Now to do the cylinder that snaps into the bottom of the pegs, the cylinder outer diameter needs to be tangent to the pegs. So I can click the tangent constraint, edge of the peg, edge of the circle, tangent, edge of the peg, edge of the circle, edge of the peg, and edge of the circle. We can tell it locks it in place because it turns black. Now I can draw another circle at the center of that, and this circle is going to be a diameter of the peg, so variable peg diameter, and there's the size of the cylinder on the inside of the Lego block. Now if you happen to be only doing a single unit brick unit wide Lego, you wouldn't have a cylinder like this, you'd have a solid cylinder. So as an example, I will do that here and then erase it. So to do that, I would project 2 circles. So if you're doing a single wide Lego brick, not a double or a triple, you just want to project 2 circles down below and draw a circle between them. Use the tangent snap to snap this edge of the peg to the edge of the circle, edge of peg to edge of circle, and then use the horizontal or vertical constraint to tie the edge center of a peg vertically or horizontally to the center of that circle. So now we would extrude this circle instead of this circle if we're doing a single wide Lego. I'm going to Control Z through that process because that's not what I want. Oops, Control Z a little bit too far. There we go. So now I have where my cylinder is. I'm going to turn the block over, and shell first. So shell, I click the bottom of my block, and my shell thickness is how thick I want the outside wall to be left on my Lego, which happens to be peg height. So variable, peg height. Click OK. If you look at it from the bottom again, we can see these peg circles are tangent to the outside line of my underneath of the brick, so I know they would snap together in real life. Now, I can extrude this cylinder down into my Lego block by saying extrude, clicking inside the cylinder, and instead of doing a blind depth, I'm going to change it and say up to part, and then just click the Lego so the extrusion runs into the Lego and then stops. If I like it, I can say OK, and there I have one cylinder. Now I use linear pattern again. Again, I want to use a feature pattern. Click my feature, which is extrusion 3, or I can select it from my menu. Then I choose my direction. I want my direction to be parallel to the direction I want the cylinder to go. My distance apart will be my variable brick unit, and my instance count will be 3. Tab to confirm. If I like it, I click OK. So there. I have basically 3 cylinders attached to the underneath of my Lego with a 2x4 peg system on top. The last thing I can do will put text on top of my Lego, and then I can pattern that. So again, new sketch, view from the top. This time I'll use the text button. And when I draw the text, I want to make sure it starts on one side of my circle and is tangent to the other side of my circle. Now I can put in my text. And you can choose your different styles text and see what you find you like. Not all types of text are available in Onshape that there are in Microsoft Word, but you do have some. Now you can readjust your text so it's in the center of your block. Get it up there. There we go. Click OK. You can extrude that. And I only want to extrude it a very short distance, something 0.1 millimeters or less. That's all we needed. Now I can pattern again. This time I'll do feature pattern again. However, sometimes you'll end up choosing something to pattern that may be attached to multiple features. For example, had I patterned the peg with text already on it, or extruded the peg with text already on it in the beginning, I wouldn't be able to do the shell, and I'd have to go back and then pattern the text without patterning the peg. So one way to do that is what's called a face pattern. Sometimes if you need to pattern something that's not attached to a particular feature or has multiple things attached to that feature, faces work best. So to do a face pattern, you want to select the face of all the text that you want to pattern. So to do that, if I draw a rectangle from left to right, we see the outline is blue and solid. That rectangle only selects what's in the rectangle. So all it's going to select is just the text. Had I drawn a rectangle from right to left, the rectangle is orange and the line is dotted. That would select anything the rectangle touched, which would include the peg and the brick as well, and we don't want that. I just want to select the text. So you could have done an extrude pattern on the previous extrusion to make the text, or a paste pattern on just the letters of the text. Now I choose my direction. Change my distance. Again, brick unit. My number is 4. Tab to confirm. I want to do a second direction, so I can go down. Choose my direction parallel to down. Distance again, my brick unit. Instance count 2. Tab to confirm. Looks like it's going the wrong direction, so we can click the opposite direction button. And there we go. So we'll say OK. And there you have it. Your Lego's complete. Now that you've used this, you've created the variables, this can become your part studio. So you can create numerous Legos in this part studio by just turning on and off parts you no longer want to look at in the studio and creating a new sketch on the top plane to draw the rectangle. For example, here's a part studio of the various types of Legos my students have built after learning how to draw Legos. Once you've created a Lego, or once you've had students create a Lego, you can import that Lego into the parts bin. They can do that if you share the parts bin with them. And then they can use the derived feature to import it in. To see that, there's a video on it that already exists. From here, after I've checked my students' Legos, I will import them into my much larger Lego folder to make sure I only import ones that seem correct. So here I have a folder of lots of different types of Legos that we'll use to build assemblies with as they learn how to do it. Alright. Thank you for watching.